We're still streaming, because bouncing the stream does not always guarantee that it will come back up. But it looks like it has. Maybe. Or is that the old stream? I can't tell! Ah. Oh no, the old stream has like a Firefox logo on it. That's right. Alright, now I'll go tell the world that I'm up. Now that Firefox has installed its updates, hopefully one of them will prevent the memory bug, which prevents OBS and Firefox from getting along. Every time I do one of these streams, I have to close down Firefox until the stream is running. Or it can't do screen capture. How interesting, right? Streaming game dev. Gonna do maneuvering jets for spaceships. Paste. Alright. So, in the past couple of weeks I've been working on this prototype, and obviously I think it's probably a little disappointing to some of you because it doesn't look as nice. That's the problem with these early stages, is they look like shit. So I had a couple of options. One option is I could model some better looking stuff today, or I could do some maneuvering jet work, or both. So let's go ahead and model some ship parts that look a little bit better than this piece of crap. I don't know whether or not we'll get around to putting the maneuvering jets into the game world today, but I might do it off screen if we don't. There are some unknown entities there, some pieces that I'm not sure about, so it might be a good idea to do that off screen so that you guys don't have to watch me fuddle through it. I've got all I need about, rotating maneuvering jets into place and firing them in the correct direction and stuff, but I don't have any of the, well, actually, I do want to do both. Okay, so we're going to do a little bit of modeling, and then we're going to do a little bit of maneuvering jet stuff. We're not gonna model every single piece that we need. I don't even know what this is. Simple pipe. I don't think we're using that. Most of this stuff we're not using yet. So what I'm going to do is these here are placeholders for our maneuvering jets. So what we're going to do is we are going to go ahead and put in a proper maneuvering jet looking thing. And the easy way to do that is to make sure that we have all of the things we need to have. And that should be pretty close to everything. Oops. We'll just go ahead and delete all those faces, and that gives us a fairly clean result. We got some floating islands here. Oh, come on, I'm clicking on the island. There you are. Anything else? No, it looks pretty clean. So what we're going to do then is just bridge these. Oop, that's not correct. There's something wrong here. Oh, that's interesting. It looks like this raised element is no good, so we're going to have to delete it too. And we will just go with this guy, the base. And then when we merge these face loops, like so, we get this sort of setup. We're going to want to do a lot of editing here to make this feel a little bit better. And one of the tricks we're going to use is a lot of extending and expanding around from our cursor. Because that means that we don't have to unmirror things. Because right now it's mirrored, and if you expand while you're mirrored, all sorts of dumb things happen. So if we do this instead, we can avoid those dumb things. That's good enough. So what we're going to do now is scale these on the y-axis from their median. There we are. And we're going to turn this into rails. And I guess the best way to do that is, in fact, to unmirror them so that we can edit these without having to worry too much about the mirroring. So if we're going to switch it over into rails, we've got a couple of options. One is to bring it down inside like this, in which case it's got lips. Another is to actually bring it out like this, in which case we can have maybe something that clamps onto the outside as it spins around. To be honest, that sounds pretty cool, so that's what we're going to go for. And then we're going to just go put this guy in, bevel him a little bit, and then extrude them inwards, and that's going to be the rail that the jet spins around on. We need to develop the jet now, and it has to be a separate object from the core engine for a variety of reasons. But since it has to fit perfectly, we're going to go ahead and just select the faces that it needs and clone them into a new object. So duplicate and then punch out. And this is our rocket all-around, what's it called, maneuvering jet. The idea of this maneuvering jet being that it's going to spin around the rocket. Of course, right now, it's not anything, so we're just going to go ahead and make it work. There are a lot of ways to model stuff. Normally speaking, I would have modeled these things more at the same time, rather than I'm kind of doing some stuff after the fact here, and it's just kind of thrown together. But basically, it's not that big a deal. We're just going to go ahead and seal off this object, like so. That'll do. We could split it in half and use a mirroring tool on it, which would probably be a better option. So let's go ahead and do just that. Go over here, mirror on the wall. There's the x-axis. Perfect. And then we can close off this edge here. So the idea is we want this to look fairly reasonable, and there's a lot of ways to do that. One of those ways is going to be to fix this. It's not right. So this is a 3-part split here. And so what we need to do in order to make that work is to have it split up into 3 here and then join these. That way we actually get the faces we're going to want. And the reason that's important is because I plan to do some beveling, like always, and I would prefer it if the bevels made some modicum of sense. So you can see that these bevels do not really make a whole lot of sense. Well, they're not too bad, I guess. It's just that these really sharp edges bevel so strangely. Yeah, I guess that's probably fine. What we can do is we can manually massage some of these back into place. There we go. We're also going to want to do some adjustment here so that we have a good feel. And that means we want it to feel like it can spin around. And to do that, we're going to bring this out like a shuttle. If we bridge this like so, we can make it seem a little bit more rounded. This does have a problem with this corner face here. So we're just going to bring a loop around. Let's go ahead and undo that. You might be asking, why are you undoing all that stuff? Because I want to get it clean before I bevel. If I do it dirty and then I bevel, things go to hell. So it's better to do it clean. All right. Elbow Etchy says, I'm asking questions. Do you know of a place I could get data sheets for embedded DisplayPort standards? VESA is rather secretive about it. Sorry, that is not my field. I know absolutely zero about that. But seriously, good luck. So if I were to bring this up, you can see that we don't have quads here. What I think I want to do is actually have it bend again here and here. And then what we can do is bring this up like so. We still don't have quads, but we can fix that by just adding in some more cuts, obviously. These things can also be done with a bridge edge loop command, but there's only a couple of pieces, so it's not that important. The idea here is that now I can drag these faces forward. Maybe even these guys. And that will feel a little bit better. And there are a lot of things we can do to punch this up. Let's grab this face and just drag it back a little bit. We'll get ourselves a nice sort of feel there. One of the issues is that we go straight up vertically, and that's a little bit aggressive. But if we scale down on the y-axis like this, and then like this, oh, I accidentally extruded here. Scale, not extrude. There we go, something like that. And what I'd like to do is have this be something that has vents on top, which is why these aren't wasted. We're going to turn these into vents. How exactly the vents look, it depends on how you want them to look. But the basics here are we're going to need to cut it like this. There's a lot of different ways we could do that. I think this will work. And then what we'll do is we'll grab these faces and we'll just cut them out. That didn't work. Can we grab them one at a time and cut them out? Why can't you rip the selected face? Fine, we'll just delete the selected face. See, so much better, right? Well, we can't really delete it either. I really need these ripped out. Okay, we'll just duplicate them, move them up, and then delete the old ones, and then move them back down. There we go. And why did I do that? Because this way I can actually turn them into vents just by splitting them like this. So I need to make sure that I get the right number of cuts. 15. Sounds good. As long as it's the same on both sides, I'll be happy. Then we're going to just select these and do a checker deselect. Oh, it only did a checker deselect on one of the halves. That's interesting. So we'll go ahead and just do them separately one at a time here. So that's a checker deselect, and then that's a checker deselect. Oh great, they selected alternate checkers. You bastards. Fine, do it manually. There we are. And we'll just drop these in, like so. You can bring them deeper than that. And that's going to be our maneuvering jet. It's pretty basic, but you don't need anything too complicated, as long as it feels right. There are a couple of other things we could do to try and make this maneuvering jet feel a little bit better, and one of them is we can skew it a little bit so that it's not quite as vigorous of a slant here. So if we were to switch over to individual verts, I have a hard time seeing the screen at the minute. Oh no, not Control-Shift-S, Control-Alt-S. What's the skew? Is it just Shift? No, it's Alt S. No. Control S. No. Crap! I've forgotten the skew command. Elbowichi says, "Is it often that one needs a checkered deselect?" Yes. Yes, it's really, really often that you need a checkered deselect, or any combination of complex mathematical select and deselect operations. Every single modeling software except Blender does it. Blender has this checkered deselect, which is like a half-assed implementation that doesn't really work right. But if you're doing any kind of machine work, you know, hard surfaced machines, you often need to do really, really complicated select and deselect functions. So let me just look this up. Blender skew shear. That's fine. Control-Alt-Shift-S. Oh, so it's all of them at once. Okay, I can deal with that. Control-Alt-Shift-S. There we are. And then we'll want to make it a y-axis. Come on, come on, come on, you can do it. Yay. I'll drag it down a little bit. There we are. And that'll flatten the top out a little bit, which will get us a little bit better visual. Obviously, this vert is a little bit awkward, so let's drag it down. There we are. That'll do. Now what I want to do is, this edge is a little bit weird looking, and I'd like to fix it up a little bit. There are a lot of ways to do that. I think what I'm going to do is create a bridge. So we'll just go into individual origins here and shrink them down like this, and then extrude them up, and then extrude them up again, and then we will just grab these guys and merge their face loops. And then we will just go and adjust this until it looks like something we're happy to have detailing our ship. Oh, need to go back into median point here. There we are. And these can be pulled out just a touch. That's more or less right. It's a little wobbly, but it doesn't matter. This is a low poly solution anyway. It's temporary stuff. So this is what will spin around as we change our vector and vent air upwards. That said, I think that it might be too much engine. Let's go ahead and tweak it just a touch to kill a little bit of these vents, just like that. Boom. And then what we can do is cut here, and then select here, edit mode, active elements, select Y0, oh, select X0, cut here, select YX0 there. Oh no, it doesn't, it's not quite flat. None of these are quite flat. That's fine. What we'll do is we'll just grab all of these top surfaces, scale them to the same Z point, and then we will merge all of our doubles, and then we should have a nice connected face, which we can now cancel like so. That'll make it so it doesn't, so it feels like there might be a little bit of room for machinery in there. We can also detail this slightly if we feel like there is not quite enough detail for our system. What I'm going to do is I'm going to detail it on a slightly different scale, so that it feels like it's not so rigidly divided up into thirds like that, or halves, or whatever you want to call it. By just making it on a slightly different line, it'll look a little bit more interesting. And we'll just bring this down. There we are. Perfect. Yeah. Very simple, but that's all we need. All we really need. Yeah. The fact that the checker deselect is so bad in Unity, to the point where it's just called checker deselect. Everyone else has about 8 different versions that do different things, was one of the things that really upset me about Blender. It's not very good for modeling hard stuff, by which I mean robots, not like complicated stuff. It's just the nature of the beast. All right. Now the only problem with this is that it is not pointed in the same direction as the actual engine. So this engine does a Z-axis thrust, as you can see, but this does a Y-axis thrust. We're going to have to be a little bit careful about how we spin this so that the Y-axis works, or we can simply rotate it. So even though the rotation is not required and takes it off of the object if we do it, this will make it easier for us to do our calculations if the engines are always pointing with the same local vector being forward, being thrust. What we'll do is we'll just manually move it into place on the engine's chassis when we go over into Unity, which is what we'll do now. Alboichi says, coming from a measurements-driven CAD side of things, I can't really work with Blender. I can't get the feeling of not using strict lengths. Yeah, Blender's use of different local and global measurements could probably be very confusing to a CAD user, because you can scale verts, but you can also scale, like you can scale the vert chunks, but you can also scale the object, and those are considered different scaling operations, even though they have the same result to your eye. That's confused me more than once. So what we need to do is equip our new thrust system. Unfortunately, it appears that we forgot to save. There we are. So we're not using any complicated material systems yet. It's probably worth going in and doing some of the basic material work now. Otherwise, it'll be like a big load of crap that we have to do later. So we're going to go ahead and use hull. And we're going to just use this as vent. And it's pretty obvious what we're going to do with what here. Most of this stuff is going to be hull, but these areas are going to be vent. Let's go ahead and make the underside also a vent. Trying to think of the easiest way to select these faces, but I guess sometimes the easiest way is just to manually click on them all. Now there's no UV unwrapping at the moment. Let's go ahead and make this a vent as well, now that I'm thinking about it. There's no UV unwrapping at the moment. We don't really care too much, but it's best to have at least something on the books. We're going to repeat the process here. We've got hull, we've got heavy hull, we've got vent. So here's hull, here's heavy hull, and here's vent. And now when we go inside, this is vent. And this is heavy hull. And then we got some more heavy hull here, 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 here. Lots of saying here over and over, I think really helps the stream to stand out. I am the only man who says here quite this much. It looks like we have some broken sinks, some broken merges. We'll deal with that later, I think. Those are all heavy hull. So if we wanted to, we can change these values in here, and they will slightly change in Unity. The Unity versions of these aren't quite as good, but they'll sort of work, and that'll be good enough for us to get a good idea. Excuse me, I just sneezed directly into the mic because I was all contorted up funny. I'm sure that was a wonderful sensation. Alright, so now we should be able to see a little bit of color on these guys. These have the wrong materials assigned because they are leftovers from back in the olden days. So we'll just go ahead and manually drop some materials on them. The materials by default are these guys, so we'll just go ahead and we can't drop it on something that doesn't exist, so we have to manually enter them in. What a pain in the ass. Where are the materials? They should be right here, right? Oh, they're there at the bottom, I see. 3. And then we'll do the same thing for the other rocket. 3. And then we will drop the correct materials in hull, hull, vent, vent. Much better. Elboechi says that I must always get that feeling where words lose their meaning because I said them too much. Yep, that's me. So now what we need to do is extract out one of these rotors, one of these maneuvering jets, which we'll do. Just drag it onto one of these rockets, like so, and delete this guy. This rocket all-around maneuvering jet, we'll go ahead and place it in our rocket. There we go. You can see that it is rotated in incorrect direction, but as I mentioned, that's kind of the point. Dunk. Now it's correct. See that? Lovely, lovely work. What we're going to do is we're going to set this up so that it will spin around the up axis, its local up axis, and allow us to get vectors off to the sides of the main rocket. Snowstate says, hey there. Hey Snowstate, I'm working on maneuvering jets. Just putting together some prototype visuals, and we're about to roll them out into an actual effect. Something that can spin. Won't that be fun? So here we've got the thruster. We're going to need to have an additional system called the maneuvering jet. Although to be honest, we might not need to have an additional thruster called an additional system called the maneuvering jet. Because we may just be able to mount that as if it were a rotor. Let's try doing it with the rotor system. Because the rotors are already programmed and they're very, very close to free. The only problem with the rotor system is that it is descended from the same thing that the rocket thruster is descended from. They're both descended from controllable ship systems. So this does mean that there will be two controllable ship systems on the same object, which may not be the best thing we can do, but it should be okay. And the last thing we need to do is put on a physics component. I guess that's not the last thing we need to do. If there's no box collider here, there's no collider at all. So let's put on a box collider. I don't think we need to have a mesh collider for this, but a box collider should be fine. Snowstate says, what game are you making? Well, that's a good question, Snowstate. So for a while I've been working on a game called The Galactic Line, but this is sort of a sub-project instead. Uses some of the same assets, but basically it's a game where I created a pretty nice little physics engine, and it allows me to do some stuff with spaceships that people haven't really been able to do in games, but we're still in a very early state, so it's very ugly. But because the physics system is very fast and flexible, if you've ever played something like Space Engineers, you know that using rotors is often cataclysmically difficult. Well, in this system, it can use them really, really fast and rapidly with no slowdown or confusion. And many other kinds of systems can be implemented in the same kind of fashion. So it should allow for really big, complicated ships, even on people's low-end machines. That will be super nice. But as I said, it's very early on, so we're not really in a state where it looks pretty just yet. Yep, you are right. I must have scaled the image wrong if you can see the taskbar. Let's find out here. OBS is... Oh, I see. It's like 1 pixel, huh? I wonder what the change is. That's odd. Am I in the wrong... You know what? I bet I'm in the wrong profile. No, I'm in Screen Stream. Or is Screen Stream not the right profile? I'll have to look into that later. I can't change the profile without bumping the stream entirely, and I don't feel like rebooting the stream. So what I'm going to do is just leave it like that. It's not like there's anything terribly catastrophic down on my taskbar that's going to make everybody hate me. So we'll just leave it like that, and I'll try and get that taskbar back to not showing at all next week. I must have done something. Don't really know what. Well, I could scale up this game dev 1 pixel, like just to there. Yeah, that'll do. And then yeah, that'll do. Good. I quote unquote fixed it. Well, when I'm streaming, the only thing on my taskbar are the things that I use to stream. So that means right now it's just browser with Twitch open, browser with Twitter open, and all the OBS and Unity stuff. Oh yeah, and one icon that shows that I can open up a file browser. Shock. Okay, so what we need to do is I'm not 100% sure that this rotor will detect engines that are on the same object. So that's what we're going to check before we do anything else. Align thrusters to vector. This gets the thrust vector here. If we look at our thrust vector calculations, there it is. What we do is we get all of the components in children that contain the thruster. But I don't know whether or not get component in children gets components on yourself. So I may have to add a second line. We will see nowish. It seems to be doing something. So it definitely moved to try and orient the system, but it obviously moved around the wrong axis. I believe that I can specify which axis it's trying to move on. Let's take a look here. Oh, is it? I bet. I bet that both the rotor and the engine assume a z-axis situation. It could be that the rotor assumes an x-axis. It's been a while since I looked at this. Let's take a quick look here. Yeah, the rotor has a specifiable axis. Here it is. Public vector 3 axis is up. I'm not sure why that errors out. We could try a different axis, but that should be correct. I guess the z-axis is correct for that one. That's interesting. Okay, so this rotor is really screwing up because the maneuvering jet counts as a primary thruster. So what's happening is that this rotor here is trying to align our thrust so that both the maneuvering jet and the main engine are pointed so that their systems are balanced. So it's trying to point it like this rather than like this, because the maneuvering jet counts as a main thruster. So we're going to want to break it up into main thruster and secondary thrusters. Alboichi says, your avatar and channel banner seem to be gone. Well, I didn't change anything. Let's go ahead and just check out my avatar and personal banner here. Yeah, they went away. Well, I'll have to fix that too. No, it's definitely a problem on Twitch's end, Alboichi. Great. Alright, so I have lots of annoying things to fix. Twitch sometimes changes things and doesn't tell me why or where or how. I'm presuming that what they did is they changed the banner size and invalidated my old stuff. Because I certainly didn't change anything, and I didn't get hacked as far as I know. So, whatever, right? Let's go ahead and set this up so that the engines have various capabilities, and we only get the capabilities that we're tagged for. With that in mind, we'll go over to the thruster here. Let's go ahead and close down a lot of this stuff. We don't need it at the moment. Perfect. So here in this thruster, what we're going to do is we are going to call it with a specific engine type. Now we could use an enum for this. We're going to use a string. This is useful for modders, but it also might be something that we do change to an enum later. Public string engine type equals main. And that's just going to be the main thrust that you normally get out of an engine. We'll add in like maneuvering and then later on like light speed and stuff. So there's going to be a lot of differences. You might have air breathing, retrojets, stuff like that. This will allow us some flexibility there. Over here in the rotor, we're going to want to have it known what sort of thrust vector we have based on our based on which thrust element we are currently looking for. So for that, we're going to go ahead and put in this, make this a tooltip. The type of engine we're orienting, blank for none, all for all. I guess we could do, yeah. See, there's going to be lots of thrusters where we're not actually orienting engines, so I think blank for none is great. Alboichi says, are you planning to return to the galactic line, or am I just going to cannibalize the assets? Kind of both and neither at the same time. There's not really any reason why this can't lead to the galactic line, but this has the big advantage of requiring about a quarter of the effort. Because it's so much easier than the galactic line, and because it's its own project, I can do the opposite. I can do this, and then I can cannibalize this for the galactic line. But having a project that I can release is a priority, and the galactic line is like 2 years from release, whereas this is like, 8 months. So I'm not worrying too much about that. The idea of a dollhouse in space is still a very strong one. But this features several pretty cool features that I haven't seen anywhere else, and it's also approachably sized. It's not a huge game like the Galactic Line is. But if you have strong opinions, by all means, let me know. Anyway, here in thrusters, what we're going to do is only take the thrusters that aren't our engine type. So first off, this only happens if we have an engine type. If engine type equals this, or engine type equals null, return vector 3 dot forward. Fail gracefully, quotes. All right, so with this in mind, down here in the thrusters, we're going to say if engine type does not equal all, and engine type does not equal t.engine type, continue. So the problem here is that if the thrust vector is 0, it could be an issue. So if thrust vector dot magnitude equals 0, debug.log warning, name plus has no matching engine, it's useless. Elboetchi says, have you talked about this before? Have you thought about integrating the physics system into the galactic line? If so, both projects would benefit from the work. I don't honestly know. The galactic line is primarily about the stresses that your crew is under as you fly about the galaxy. The physics system could be useful because it allows for complicated damage types to your ship, but I'm not sure that that's going to be very useful for the idea of characters that are feeling things and, you know, undergoing stress. I may make it, I mean, there's not really a huge problem with integrating them together, except for the physics system also shines best when there is something to bounce off of. And the vast majority of the time when you're in the galactic line, you're between stars. You're isolated from the rest of the world, so rest of the universe. So I'm not sure there's any point to combining them, but they're definitely sister projects. All right, so here we have a line thrust of vectors. What we're going to want to do here is this thrust vector. We're going to want to do a quick check and make sure that it exists. So if thrust vector dot magnitude equal, no, not dot man, magnitude equals 0, return no thrust. And that should do it. Now all we have to do is change the secondary rotor and the secondary engine to have different maneuvering channels. I've already got channel. I can just change their channel. Oh, I'm an idiot. Okay. We do not need this engine type anymore. We'll just delete that. And over here we will delete this as well. And everywhere it crops up, we'll just use channel. Oh, except for there's actually a special command, isn't there? It's t dot can sync. There we are. All right, perfect. So we can use the channels to determine what sort of things we're going to be using for each. And what we're going to do here is we're just going to use subchannel 1 for both of these. Later on we might change this around some, but just for the purposes of testing, subchannel 1 seems like a good idea. Magnitude, yeah. Elboetchi says hot damn, not sure exactly what he's talking about. Okay, so here you can see that our engines are properly aligning. They're no longer off center. Now the problem is, of course, that our thruster is attempting to orient towards the back of the thrust vector with the with our current engine. So there's a couple of things that might be going on here. See, we got this warning here: no controller for rotor cannot align. It's looking for a controller and it can't find one. That's a little bit odd because the controller should be able to be determined automatically. Here it is. It doesn't say no ship to control. No physics for rotor head will be of... Okay, that's fine. I don't care about that. Let's go ahead and change this error so that it tells us what rotor the problem is happening to. Because I think it's happening to the one we want to align, and that's why it's not moving. Yeah. So no controller is a strange error to have, since the controller is determined automatically by just looking for a ship. And this is the ship. It obviously exists. So here it is, the controller. Oh, can sync. There's the problem. So the problem is that I changed our system so that we're using a different channel, which means we stopped syncing with our primary controller. But the controller shouldn't be caring about the channel. It should only be caring about. It shouldn't be caring about the sub channel. It should only be caring about the channel. So instead of can sync, we're going to comment that out and put in a little warning here. Disregard channel, control systems, control on all, disregard subchannel, all subchannels. So here's just where we say if c.channel equals channel, return C. That's better. All right, so if we do this, and then I pause it, let's look and see whether or not our engine is rotated. So here it is. Previously it was at the top right here, and you can see that now it is somewhere else. It is down here, pointing in the correct direction to try and get us as close to backwards as possible, which is good. That's kind of what I want it to do. It's obviously wishy-washy at the moment because it's not correctly vectored. These maneuvering jets need to be vectored on the on a lateral axis rather than on the primary axis. We have no concept of a lateral axis yet, but we do need to have these thrusters understand whether they are trying to be on the lateral axis. Right now we're using the sub-channel, just saying sub-channel equals 1 for these controllers. But I don't think that really tells us whether or not they're on a secondary axis. I think it would probably be better to be really, really obvious. So public bool maneuvering equals false. And here we'll just put tooltip. Remember to change subchannels if you change this. So what we're going to do is when we're doing our maneuvering, now you know what? It's not the thruster that needs to know that, it's the rotor. No, both need to know it, don't they? Hold on a minute. We may not be able to do this with separate rotors. I need the rotor and the thruster to both orient. Well, you know what we can do? We can just change the subchannel from a number to another string. Like so. And with that in mind, what we can do is we can change it to, say, maneuvering or something. Later on, we might have to change this. This is getting a little bit too opaque. I don't like that. This is not the best approach. I'll have to think about the best approach. But what we'll do is these will both be maneuver. Like that. So when we go over here into the rotor and we ask it which direction we're looking to get, look, the thrust vector is correct, but the align thrust vector needs to be changed. Here we get the controller.heading, as you can see. What we need to do is get the controller.heading that is part of our current needs. So what we need to do here is controller.heading, we have 3 basic options. We have the final heading, we've got the main thrust heading, and we've got the maneuvering heading. Actually, we've got shit. It's not quite like that, but it's Yeah, it's not like that. It's the three that we need are a little bit different. So let's go over to the controller and figure this out. So right now we're doing pilot ring.forwards. Later on we're going to add in WSAD, and the WSAD will allow us to strafe, and that will also change this heading. But we need to have the ability for us to detect yaw and spin and all that stuff, and arrange our maneuvering jets to try and turn us in that direction. In order to do that, we are going to need to have this setup where we can ask it the relative direction of the heading it's on and the direction it's supposed to be in. So the difference between the ideal heading and the actual ship heading. And that's pretty straightforward. It's the difference between ship.forward and pilot ring.forward, at least at the moment. So we're going to go ahead and create a quaternion for that. Course change. So we're going to return a quaternion that is the from to rotation of the ship.forward. Hello, can I have the dot transform? No? Okay, fine, fuck you. And the pilot ring dot transform dot forward. A heading. There we go. I don't know why the ship dot transform wasn't filling out. It usually means that I've got a spelling error somewhere, but it doesn't. It's not popping anything up. All right, so this will work pretty well for most of the things we need, except that I don't actually want this to be heading. I want it to be pilot ring.forward. And the reason for that is because the heading will include our strafe, and our ship should not turn its nose towards our strafe. So I'll write that down. Do not turn nose towards strafe. Use raw pilot ring heading. Colt Zero says language there, Craig. I don't even know what I said. Probably shit. Alright, so that should give us the course change that we need. And in order to determine the change in the direction in which we're trying to move, we need to determine which direction we're going to need to fire in order to cause this quaternion to happen. So the problem with that is that the quaternions are a very complicated and convoluted system, and it's a little bit complex to figure out what we want to do. So what we're going to do here is we're going to go ahead and have a subsystem. So here we're going to say if subchannel equals maneuver, then we want to do align thrusters to maneuver. And that's just going to be the same thing, but with a slightly different set of values. Public void align thrusters to maneuver. One of the big changes to aligning the thrusters to the maneuver is that we're going to need to tell the engines that they need to fire or not. We're going to be setting the engines manually. Right now, when we set the engines up, we already do it manually, so that's fine. We'll just be doing it manually in a different way. I think that we actually do it in the ship control system. Let's take a look here. Update. Yeah, so the throttle axis determines some of that. Where does the thruster get its throttle set? It's not by the thruster. Oh, here it is, yeah. So well, here in update, we're going to say if subchannel does not equal maneuver, boom. We may want to have this inside of that as well, because this generates thrust. If we generate thrust with our maneuvering jets, we're going to end up moving the ship in weird directions, but I guess that's not too bad. We'll try it out one way or the other. So we'll just make a note of that. The thrust is outside the maneuver check, meaning that maneuvering thrusters will push the whole ship as well as turning us. Alright, so now that we have that set up, we still need to figure out the way to turn a quaternion into a set of vectors. The basic idea here is what we have for our... hold on, let me just go ahead and fix all this up real fast here. A quaternion is a set of rotations, and that should tell us which axes we would like to try and spin the ship on. By determining which axes we would like to try and spin the ship on, we can then determine whether we're behind or in front of those axes, and determine whether we should be firing vertically or horizontal, which direction vertically we should be firing. Basically, we're looking at a left-hand rule or right-hand rule, depending on how you look at it, where we're figuring out which axis we want to rotate around, and then we are firing 90 degrees off of that axis in order to rotate around that axis, depending on whether we're off on the other axis. So if we're trying to rotate on the x-axis, we determine whether we're positive on the y or negative on the y, and that determines whether we're firing on the z, in which direction on the z. So all three axes are involved in every single one of these calculations, but there is an easier way to do it. We can figure out what sort of vector we want to rotate based on our offset from the center of the ship and the quaternion. Now, I say that this is easier. I don't actually know how to do it. Quaternions are not my specialty. I'm not too bad with them in a functional way, but I don't know the math behind them 100%. So it may be a little bit difficult. Let's go ahead and try and figure it out. And if any of you have any opinions on the easiest way to do that, let me know. The reason I want to do it this way is because I did it the other way in the past in my prototypes, and it's a long-ass set of statements, and sometimes the results don't make any sense. Because when you're trying to spin around the x-axis, you can check and see where you are on the y or the z, but then the y or the z-axis is also a fluid concept because you're spinning around the x-axis. So you end up with the situation where you might be trying to do it in the least efficient way possible. I'd like to avoid that. In a fundamental way, it doesn't actually matter. We're going to be faking a lot of this rotational force, but I'd like it to feel realistic. So what we're going to want to do is get the offset from the center of this ship. And that would be the ship dot... Oh, okay, apparently we don't have the ship cached. So we're going to go ahead and cache it. If ship equals null, ship equals get component in parent ship. So here we're going to say offset from center of ship. We're going to go ahead and just grab this. If ship equals null, debug.log error, name plus is not in a ship. Return. So we want to find the offset from the center of the ship. The complexity here is that we don't want our offset from 0. We want our offset from the center of mass of the ship. You might be wondering how we can figure out the center of mass of the ship. There are probably a lot of ways, but what we're going to do is just put in a new set of this here, center of mass. In order to do that, we are going to need to go over into the ship and add it in. Public vector 3 center of mass. So we have all of these ship control systems here. Ship control systems. But what we don't have is a list of physics objects. The reason for that is because the physics container is actually a related object. So I'm trying to decide whether it's better to look for a physics container or whether it's better to look for the ship and then look for the ship's physics container. In theory, there might be a point later on down the line where we have physics containers inside of physics containers. But let's go ahead and assume that that's not what we're doing, and let's not use the ship, let's use the physics container. Alright, so for some reason it does not like us getting the physics container here. Is it inside of the physics? I bet it's inside of the mass. So where were we? So this is inside of mass graph.physics. There we are. Physics object. Physics container. There we are. And then down here, we just grab this and replace it. Is not in a physics container. Hurrah! And then here we say physics container dot center of mass. Now, physics container also doesn't have a definition for center of mass, just because we've never had to calculate one out before at this level. It's not that difficult to get them, so let's go ahead and just do it. Public vector3 center of mass get, and we'll just grab the center of mass. There are two basic options here. We can either calculate it and cache it, or we can just recalculate it every single time. I'm not too concerned about recalculating it a lot. Maybe later on we'll have to optimize it to do, maybe optimize this and cache it. But what we'll do is we'll just go through all of our systems and figure it out. Vector 3.0 for each physics component, PC in components. Com equals vector3.lerp. We're going to need a mass here. Float mass equals 0. And we say mass plus equals com.mass. Oh, there's no mass in the physics components? Why is there no mass in the physics components? That's weird. Mass. There's a mass. Why aren't you letting me choose mass? Oh, because it's not com, it's PC, you idiot. There we are. I don't know why I said com. Com is the center of mass, PC is the physics component. I have got to wake up. I need more coffee. Okay. So, now that we have the mass, we can say vector com equals vector3.lerp com, comma, PC.center of mass. And then it is mass divided by, or PC.mass divided by mass. And that'll get us the weighted center of mass, and then we can return that value. It's not that hard, but calculating it 100 times per frame might see some slowdown, so we're going to want to be a little bit careful about that later on. I put in a to-do. Everybody listens to to-dos, right? So with that in mind, we can get the offset of our center of ship by grabbing the physics container center of mass and detecting our center of mass relative to that. We already have a physics object attached to us. I forget what it's called. Component. So what we're going to do is we're going to grab that component and make sure that we have our correct offset. Component.center minus physics container.center of mass. So that offset from center of ship will determine how far we are from the center of mass of this ship. That will in turn determine which direction we need to fire in order to turn the ship around any given axis. Now, there are a couple of ways to calculate out what we need to do. It may be that the quaternion has some magical function. Let's go ahead and take a look. But I don't think it does. I think we're going to have to get this on our own. Yeah, I don't think that we have any magic quaternion stuff to do this, but basically, we know what axis we're going to be rotating around. It's the one 90 degrees off from our displacement from the center of the ship, and from our own rotational center. So the axis defined by our rotational center, by our rotational vector and our vector from the center of the ship, determines our thrust vector possibility. You know, that determines the axis around which we're going to be needing to do things. So in an ideal world, for example, if we're offset backwards on the z-axis, then this offset from center of ship will be a pure z-axis thing. If we are then rotating around the z-axis, they will line up perfectly. But if we are rotating around the y-axis, then we're going to only be able to fire on the x-axis, if you see what I'm saying. Whereas if we are on the z-axis, we'll be able to fire wherever we want. What we need to do is determine what our sweet spots are, if any. I'm not sure how to do this. It should be a fairly straightforward operation, but I'm having a hard time thinking it through. We've got two axes, and if they are perfectly aligned, then we have a complete 360-degree freedom to point in any vector we'd like. But more complicated than that, we also have a rotational vector where we're trying to figure out how we're trying to rotate the entire ship. Those three things combine. So we've got our offset axis, we've got our rotational axis, our axis of freedom, and then we've got our intended rotation, which is a quaternion. If we take a look at the quaternion heading change equals controller dot heading change, course change. This course change tells us the amount of rotation that we're trying to accomplish on the ship. What we're trying to do is figure out how it is when we offset. If we take a vector and then offset it, what happens if we take our offset from the center of ship? Let me grab a piece of paper. Oh, I should do this in my art program. Especially since I don't know where my paper is. I could draw it on the back of a takeout menu. Okay, well, let's go ahead and pop up the art program and sketch it out in Clip Studio, just so that we can figure out what is up. So basically, we've got a quaternion. Oh, wow, that's not working at all, because it's an eraser. So we've got this. Maybe I should pull out my pen. Drawing with the mouse, not so great. Yep. All right, so we've got a quaternion, which is a rotation. This isn't a transform or a vector 3 or anything. It is a rotation, and if we turned it into a transform, it would be considered a rotation around 0, 0, 0. So what we can do is, if we have an offset from our ship, say we're on the z-axis, offset, if we were going to rotate it across this quaternion, if we turn the quaternion into a matrix, and we assume there's no scaling or translating, then when we rotate this vector, we will end up with a new vector, a rotated vector. And that's where we want to be in our magical rotated ship. This would be the travel, the delta. And if we wanted to accomplish that, thrust vector. I think this might work. This is way, way easier than the old way. It's just hard to figure out. Can anybody see a problem with this approach? This approach seem good? By rotating the offset from the center of the ship, we can figure out the direction we're trying to travel, and then we can do some standard IK to figure out the direction we want to fire in order to be closest to traveling in that direction. I think that that seems like a great approach. If it doesn't work, I'll cry. Alright, so we've got our Quaternion, and unfortunately the Quaternion has no built-in way to do these operations. We have to change it over into a matrix, as far as I know. But let's go ahead and take a quick look here. No, there's clearly no... yeah, there's nothing here that actually figures out what we need. But if we do a matrix 4x4, we should be able to get a Quaternion through this here. Is it course change dot? I know that you can turn these into matrix 4x4s. I just can't remember how. I think it might be course change 4x4 equals new matrix 4x4. There's no overload. Hold on, let me look it up here. Unity Quaternion to matrix 4x4. Creates a translation, rotation, and scaling matrix. Yes, that is correct. Except I'm pretty sure that this is not the matrix 4x4 I'm thinking of. That's interesting. Jesus, people are suggesting doing it mathematically. I know I've done this easier. Matrix 4x4.trs. There's what I'm looking for. Okay, so you can specify a matrix 4x4 using the TRS function. Here it is. Is there just a rotation? Was I blind before? How did I not see all of these until just now? So if we take a look, you got translate, transpose, and TRS. There is no there's scale. There's no specific ortho version of this, so we have to do the full TRS, I guess, which is not great, but it's fine. Vector 3.0, course change, vector 3.1. And now what we need to do is transform our offset through that matrix. So offset from center of ship, vector 3, new offset, or ideal offset, equals course change 4x4 dot, and then we should be able to transform any given point. You better be able to transform points. Yeah, there's multiply points, multiply vectors. Do I want to multiply a point or a vector? I think it... actually don't... I think one of them uses the... I don't think there's any actual difference in this particular situation because there's no translation involved here. I just wish that the connection between the matrix 4x4s and the transforms was more clear and they used the same language. It shouldn't matter. So one question remaining here is whether or not this is in the correct space. So what we've just done is we've taken the global world coordinates for the center of the ship and for our position, and we've now rotated them according to the changes that we need. So we now have a global world world coordinate for our delta. So this is world coordinates for our ideal movement to So from here, what we need to do is actually figure out what sort of thrust we would like. So I was going to do this as two completely unaligned systems, but it makes far more sense for us to have a thrust vector getting system. And as it turns out, we already do. It's right here, get thrust vector. What we're going to do is have a secondary get thrust vector, get maneuvering thrust vector, and it's going to do all of that work that we just did. With the key to keep in mind that we are returning world delta, not local delta. So for that, what we need to make sure to do is say so. Gets the world space maneuvering delta for our engine. No problem, right? Up here on get thrust vector, let's take a quick look. This determines the actual thrust vector. Okay, so that's not what we need to do. We need to get the intended thrust. So hold on, let's go ahead and change this up a little bit. Get intended thrust vector. And what we're going to do is get the world space intended thrust vector for our engine. Different based on whether we're maneuvering or not. So down here what we'll do is if we're not maneuvering, if not subchannel equals maneuver, then we're going to just return the ship's heading. Okay, so hold on. Do we have a ship controller.heading? My bad. Otherwise, we'll want to return the delta. Now that's always going to be in, that should be negative heading. Here we are. That's always going to be correct. So down here, we don't need this anymore. And instead what we need to do is this here, when we get this negative controller.heading, instead we're going to go ahead and replace that with get intended thrust vector. And that should get us the intended thrust vector regardless of whether or not it is a maneuvering thruster or not. Now we're having a real hard time determining whether or not the maneuvering thruster is on or off because these particle systems don't really exist within it yet. So we're going to go ahead and paste those inside of our maneuvering jet and change their rotation so that they are properly rotated to match, which should just be 90 degrees up like this. The only problem is they may fire off with this rocket. So we're going to go ahead and go into the rocket and make sure that it only searches one layer down for those maneuvering jets. But let's go ahead and fix whatever it's yelling about here. If subchannel does not equal. An object is required, return vector, return negative controller.heading. And best overloaded has some invalid arguments. Multiply vector course change. Oh, because I'm an idiot. Offset from center of ship. Thank you for catching me. That would have confused me for ages. All right. So now let's go in and make sure that our rockets only search one layer deep for their particles here. Oh, it looks like we have rigged them up using Unity events rather than, yeah. So that's fine. We're not even searching for them. We're going to want to go ahead and add in this on throttle frame for our new particle systems. Boom, perfect. Save that, and let's take a quick look. All right, so I can't see them very well because they're so small. Maybe we should change the camera just for a little bit so that I can actually see what the heck I'm trying to see. Yoink and yoink. That ought to give us a better view. So as we move up and down, it's not adjusting itself at all. It does, however, say that rocket all-around maneuvering jet has no matching engine. It's useless. So this problem here is cropping up. What sort of issue is that? Because this should have... Oh, you know what the problem is? Subchannel is not maneuvering. It's C? Why was it C? That was bizarre. I must have just accidentally typed C at some point and it got all confused. Alright, so you can see that it's kind of wobbling around. That's because we're not trying to move anywhere right now. As we try to move, it tries to orient itself to fire in a direction that makes sense. However, it doesn't appear to be trying very hard. Right now I'm moving mostly left and right, and it's not really orienting very well. So if I were to move left, you can see that it's pointing up, which is not the correct direction. And now it's pointing directly to the right, which would have been right 10 seconds ago. If I'm moving right, it's not moving in the correct direction. Sort of is. That's interesting. There's something... I can't tell which part of this is malfunctioning because there are so many pieces. So let's go back into our code and take a look. We'll put in some debug statements to try and figure it out. Here in our setup for aligning the thrusters to vector, what we're going to want to do is set these up so that they have a bunch of debug statements. So we're going to go ahead and put it inside of the getIntended thrust vector, because this is the thing that is probably causing us the biggest issue. So we're going to go ahead and just put in some debug statements. Debug.log maneuvering jet says it's at offset from center of ship, wants to move ideal offset. If it was 180 degrees off, I'd be happy, because that's easy to figure out. So here you can see that it's giving us a fairly big rotation, even though we are not trying to move at all. We don't have any motion hooked up here. But I can see the problem already. I forgot to subtract, didn't I? I did. It's the ideal offset is not what we're looking for. The delta is what we're looking for. It should be 0, 0, 0. Yeah. So here you can see it's 0, 0, 0, and that's fine. As we move right, it says that it wants to move massively up on the z-axis and a little bit on the x, which isn't right. So as we want to move up or down, it says y-axis and z-axis and not much on the x. I don't understand, because when we're moving left, it should be trying to move on the x-axis, because I mean it's offset from the center of ship pretty bad here. Well, if we take a look here, let's go ahead and just do a quick little check. According to this, it's at negative 2.3, negative 4.7. So in other words, it's back and to the left. Back and to the left. There's a reference nobody will remember. And if I were to move this way, I would expect it to pause. If I am rotating this direction, then that means that the ship is trying to rotate, and that means that around the center of mass, which is around here, it will want to rotate back and to the left, further to the left and slightly less back. And that's exactly what we're seeing, further to the left and slightly less back. Okay. So that weird erroneous z is not a weird erroneous z at all. That's actually accurate. That makes sense. So let's go ahead and see whether or not trying to move upwards. When we want to move the nose up, it should try and move on the y-axis. Yeah, okay. Colt Zero says Raymarch voxel rendering is weird. Yeah, voxel rendering has a lot of interesting foibles. If you do it right, it's really cool and very powerful, but if you don't need to do it, I wouldn't. It's just a lot of work. A lot of people are making voxel-based games when they don't really need to, and they'd be better off making a game that was easier for them to program. But if you're doing Raymarching, maybe you're firmly in the category of people that know what they're doing. So these offsets are correct, but the problem is that we are not having the correct response to them. And I think that the issue is that we're not converting correctly. Let's take a look here. We get this transform inverse. What we do is we find our get intended thrust vector, and then we turn it into local space. And then what we do is we try and find where in local space is closer to that destination, -1 degrees or +1 degrees. In the end, what we get is something that should trend towards being correct. Colt Zero says that he likes to think he knows what he's doing, which is good. So the offsets are correct. I do want to move to the left and forward. For some reason, that's being interpreted as this weird wobbly vertical nonsense. So it's not even pointed the right way. Maybe it is 180 degrees off. Let's go ahead and just invert it and see whether or not that helps. Colt Zero says, have you ever heard of transfer functions? I think that depends on exactly what you mean by transfer functions. I don't know if I've heard of them by that name in voxel rendering. So this is just wrong. It's just wrong. There's something stupid happening here. And I think that the problem is that our rotor is confused. Okay, so what if we made our rocket on a sub-object? So this thruster is just a sub-object here. Yeah. And no longer on the original. Yeah, like so. Will that help it at all? No, it doesn't seem to. I think that it doesn't understand the direction of thrust here. I think there's something about this that makes the rotor believe that the engine is trying to thrust on the up axis. So if we look at this get thrust vector here, what we're trying to do is get all of our thrusters, and then we look at the thrust vectors for each thruster. The thrusters have a thrust vector, and when we try and detect the thrust vector, it's transformed back up. Okay, that would be the issue. But I'm not sure what's going on here, because this should be... These should be the same up. I mean, these are both pointed the same way. Neither of them has anything wrong with them. Let's go ahead and have thrusters with a debug line here. Debugging. public void on draw gizmos. Okay, so we're going to go ahead and draw our thrust vector, just to make sure that our rotors actually think that we're trying to fire the correct way. So to do that, we're going to change the gizmos.color to red. And then we are going to just draw a line. Gizmos.drawLine from center. Transform.position is fine. To transform.position plus thrust vector. Colt Zero says his transfer function generates a 1D texture based on a cubic spline. That's an interesting idea. I'm trying to figure out, I mean, I'm presuming you're doing a full 3D system, so you've got to extrapolate from that into a more useful texture, but maybe, okay, so this guy, the thrust vector is correct. It is up. So that's the correct thrust vector. It seems to be all around correct, except for the way that it is not pointing the right way when we're trying to turn. So now that's pointed not quite right. If we do it left here, it should be pointed up right now, and it's pointed to the left. This really, really looks like it's just off by 90 degrees all the time. It might be because the container here is pointed the wrong way. Let's go ahead and add in an empty game object here. Maneuvering rotor. We'll go ahead and drop the rocket all around into the maneuvering rotor and move the rotor into the maneuvering rotor object. Here we are. And we can change this to being on a different axis. This is going to screw up the first... No, it seems to be... Well, it's still wrong, so that didn't help at all. What is the problem here? So all of the values are correct. We know what direction we're trying to turn, but we can't figure out how to point ourselves to get that direction. I think what I would like to try is flattening the vector onto our axis of rotation. So to do that, we're going to go ahead and delta equals vector3 dot project onto plane, and then our vector. So that would be transform. It would have to be transform dot transform vector, transform direction, and then we're our axis. There we are. So we're needing to project onto a plane defined by our plane axis, our rotational axis, and we're going to be dropping the delta onto it. That will flatten out any sort of directions that we can't turn in. It'll get rid of all of our unturnable directions, which will hopefully make it so that it doesn't get confused by the large z-axis coordinates, or y-axis. So if we are to turn left here, it's definitely off. Look at that, that's ridiculous. So what we can do is, why is this not working? Let's move the delta down to below here and see what it has to say for itself. This is a little bit unnerving to me. So as we're turning left, it says it wants to move on the z-axis. This is all global space. Let's go ahead and transform it into local space, because that's what we do. So I'm going to transform, inverse transform direction, delta. And in theory, that will give us the local offsets that we're trying to get to. And you can see it's 0, 0, 0. And as we turn here, you can see that it is almost even with x and z, even though it should just be pure x or pure z. And as we continue to spin, oh, I stepped on my mouse, come on. As we continue to spin, there's something screwy going on. It's doing something weird. Let's go ahead and make a simple script here. Automatically spin. And we'll drop this onto, come on, drop this onto our, open up, god damn it. Drop this onto our pilot ring here. Public vector 3 axis equals vector 3 dot up. And then down here in update, we will say transform dot rotate around our axis. And then we'll do time dot delta time times 10. Now this will cause our system to spin on its own, at least in theory. Yeah. So this is what happens with an absolutely perfect flat spin. You can see that it is not pointed squarely left. Now it might be that I have screwed this up by simply mounting this. So let's go ahead and create a copy of this rocket, put it down here. It may also be that I screwed it up in a different way. We'll have to think about this a little bit more, because there are some other elements here that I haven't been too careful about. For example, I don't know whether or not it even counted as being part of the ship. There we are. And we're going to want to have that third rocket as part of our base. Like so. Colt Zero says another really interesting thing is he's using a gradient calculation based on the 8-bit alpha channel of the 3D texture to generate the 3D normals of the volume. Sure, that's not too uncommon at all. The only issue with the overuse of that sort of thing is that it's difficult to actually do proper transparencies if you're using the transparency channel for something else. These days, a lot of people use multiple textures for everything. So, I mean, if you're doing opaque and just opaque stuff, then that is fine. Sometimes I will use the alpha channel on, say, the metalness or something else that doesn't have much use. You know, the metalness texture. That way I can get away with stuffing it into textures without losing any transparency functionality. Alright, so the engine that is not on a rotor is just as wrong or more wrong. And it's returning to the same amount of wrong. So the from to rotation might be giving us global Z, but we're interpreting it as local Z. The only thing I can think of is that that z-axis should be what is moving towards the center of the ship, but instead it's being treated as if it were vertical. So that this should be the z-axis, but instead this is being treated as a z-axis. That implies that there's some flaw in how we are converting into local space. Let's go ahead and just take a quick look. Is this the z? This is the y. Okay. So when we say that we are moving on the z-axis in world space, that is true. We are moving on the z-axis in world space. So where is the z-axis in local space coming from? Colt Zero is continuing on with this example, which is pretty cool. Oh, so you're talking about generative stuff. Yeah, rather than painted stuff, of course. Okay, so I see. So you're talking about using a standard normal map, but using the alpha channel for some overloaded details. So he's storing the gradients in the alpha channel. Yeah, that's a good way to do it. Generally speaking, I haven't bothered to do that just because in Unity, writing to color data is actually a slow process. So I have a separate set of values that aren't part of a bitmap, just because Unity has some bitmap overhead, but that might not be an issue for you. It depends on the pipeline. But as long as you understand what he's doing, it sounds like it's a fine way to do things. Oh, I see, I see. So what you've got is he's using, it sounds like he's using a fake double manifold approach, which is a fine way to do it if you can pull it off. I'm not sure what it ends up looking like because there's a million ways to do it, but that's not a bad way to do it. The double manifold approach requires you to store the gradient around any given voxel. And it sounds like what he's doing is he's storing it, you know, the three-dimensional gradient in the RGB, and then he's storing the offset in the normal, or in the alpha rather. And that's a fairly typical way to do it. It might not be exactly what he's doing though. It depends on how you're doing things. But that said, I can't figure out why something thinks that Z is up. So when I have this, it says that it wants to move in local space on the Z-axis. So if I were to go over here into this object, this maneuvering rotor here, and change it over into debug mode, come on, debug mode, I can change this local Z, and you can see that that is exactly what the problem is. This local Z is what's causing us to have issues. At some point, this transform stopped being correct about which direction was up and which direction was forward. And the time when that happened is when I moved this into its own object. So now if I were to do this, that's better. That should mean that the local Z is a different level. And then here what I can do is rotate this back up like so. And now if I hit play, it should screw up. Yeah, that's fine. But that's an expected screw up because what I can do is change the axis that it's rotating around to being the Z axis again, like so. And now when I try and move, okay, well, let's delete this guy down here. He's kind of in the way a little bit, and we've determined that that's not the problem, so we can get rid of him. That means that we do have to recalculate all of this stuff, though. There we go. Colt Zero says, what is the rotation of the object? I think that he hit upon the same thing that I hit upon. So now you can see that it is not exactly rock solid, and we're having errors within this mass graph node. But this is fine. See, -1x and -1y. -1y. Isn't that the exact same problem? No. It's just not being flattened correctly at this point. Because it shouldn't have any y. There should be no local y. You can't get local y. I flattened it onto your axis. It should only be x and z. Right? Also, this is a problem. What's this? Did I screw up with the recalculating the ship components here? Reload object list. Guessed it connection. Oh, there's the problem. There we are. So this rotor should be doing its thing without any problems, but when I flatten the vector onto the rotor's axis, it isn't flattening onto the correct axis. It's flattening onto the wrong axis. So here's where I'm flattening. Delta equals project on plane, delta, and then the axis after I've transformed it. Now transforming a direction transforms from local space into world space, which is what I want to do. The axis is defined in local space, but my delta is defined in world space, at least theoretically. Let's go ahead and just put in some more debugs here and see what it has to say for itself in more detail. So here you can see that the local is pretty well contained as just x, but the z component is building. I'm not sure why it's building. It shouldn't be building. That's fascinating. So as you can see, it says that the jet wants to move at -1, -1.4, and that's a continuous thing. It never changes, which is very strange because in world coordinates, the movement should be quite different. So at some point, I am converting incorrectly here. I've got some local coordinates where I should be having global coordinates and vice versa. Okay, so there's something screwy going on. So maneuvering jet says that it's at offset from center of ship. And we want to move, transform. Oh, I transformed it. That was the problem. So good. It wants to move in the same direction all the time on local coordinate spaces. That is a good sign. The bad sign is that that direction is total nonsense. Why would it want to move on all three axes? There's no y-directional movement. Okay, so here you can see that it's just x and z. And in the local space, it doesn't seem to be truly local. It seems to be pretty wobbly local, if anything. So when we want to move like this, it says that it's wanting to move 1x or 1.3x and a small amount on the z-axis. And if we take a look, that's kind of what it's got here. It's mostly x-axis thrust with a little bit of z-axis thrust. But I'm confused as to why it has any z-axis at all. There shouldn't be any z-axis in this situation. Colt Zero says, thanks for the input. I didn't say anything useful. If you already get the situation that, if you already get the tutorials well enough to do them, then you're probably at the same level or higher than me, so it's not much to do there. But I am trying to figure out quaternions, and I'm just a frigging idiot. I can't figure out why this value is so bad, it's so incorrect. Protected, vector 3, offset delta. And we're just going to go ahead and set this. offset delta equals delta. And then what we'll do is we'll have a display public void on draw gizmos dot color equals color dot white. Gizmos dot draw line, and then we're going to want to this is only if we have a transform that's bigger than 0 here. If offset delta is greater than magnitude is greater than 0, gizmos.drawLine transform.position, comma, transform.position plus offset delta. So, I screwed that up. Let's go ahead and let it reboot a little bit there. So, if we pause the game and take a look, that white line there is the direction it wants to go. That white line there that you might not even be able to see on YouTube. It's a line that does not go anywhere near being in a correct spot. Oddly, like that's super wrong. And oddly, the global rotate, okay, I understand that part. That's like super wrong. There's no axis aligned with that direction. Okay, so hold on. It's spinning slowly to the right, right? Yeah, okay. I see what's going on. So it's spinning slowly to the right. So that direction is correct. We're trying to move the engine to there in order to line it up with our ideal heading. Because that's what happens when the ship spins to the right. The engine is supposed to be here. Good. That part is right. Now, what happens is I want to flatten that onto our transform. And now it should be strictly flat and not at all, you know, setting off in an awkward direction. I don't see it. Oh, there it is. It's aligned with that red line. Okay, so it's actually correct right now. It says it wants to move this direction, which is correct, and the thrust is aligned with that. Of course, the thrust is backwards, so let's go ahead and invert the thrust, but that is at least correct. Okay, so that looks good, but now it's veering off and up. See that? That doesn't make any damn sense. What the heck is it doing? So it says here that where we're trying to get to is this white bar, which is perfectly flat and horizontal. Can you even see that? It's on the flat plane. There is no vertical element to it at all. It wants us to go this direction. But it has decided that that means that the engine should fire this direction. Is this a problem with the IK? Oh, geez. I don't know what's going on here, and I've been at this for 2 hours now. I'm going to probably have to finish this off screen. So I came up with a really clever way to do these maneuvering thrusters in one operation instead of 8. Very simple system, but unfortunately, at some point, I've got some conversion issues, and it looks like it's ending up pointing the rockets in strange directions. It may very well be that the inverse IK has a bug, but it could also be that there is something screwy going on there. So what we're going to do, here we've got our rotor throttles. Throttle target velocity equals negative max speed. So that's the throttle for the rotor, not for the engines, right? What we need to do is tell the engines what sort of vector they're looking at if we're in maneuvering. So to do that, we're going to need to grab their thrust vector if we're in maneuvering it only. So if subchannel equals maneuver, float throttle override equals thrust vector dot, I guess it's vector 3 dot dot, thrust vector, target vector. And then we'll go through all of our engines for each thruster T in thrusters. If this nonsense, otherwise, T dot thrust throttle equals throttle override. There we are. That should do. And that will allow us to theoretically set the thrust for these maneuvering jets based on how aligned they are. So you can see that that is heavily aligned. I actually have a hard time telling what's going on. Let's go ahead and select the rocket engine and take a look at the thrust. I don't see any. Here it is. So our throttle right here, 0.70. Let's go ahead and just take a look at that. You can see that it goes up to 1 and it stays at 1, which implies that those two vectors are perfectly aligned, and that is in fact the direction that the IK thinks we should be traveling in. Oh, people are talking here. Colt Zero says there's actually something that worries me about the alpha channel value. If he's using it to derive the normal and sampling the transfer function, does that mean that the texture has to have a specially designed alpha channel, or is it as simple as sampling a regular color channel? Well, I mean, if you're using the alpha channel for something else, then that's problematic. But it sounds like it's just using it for double manifold calculations and not for display purposes. So, I mean, displaying the double manifold, yes, but not like printing out alpha textures or anything like that. It's a specially designed alpha channel in that it has that role, but there's no difference in the data structure between it and any other alpha channel. It's still the exact same data structure. You're just using one of the channels for something a little bit unusual. Now that said, a little bit unusual is also this. It says that we are trying to fire in that direction and we're perfectly aligned with it. So there is something wrong here. The delta that it has is correct. This delta is the direction we're trying to move, but for some reason that gets distorted. So let's go ahead and add in a debug here. Debug.log thrust versus target, thrust vector plus verse plus target vector. This is going to be noisy though because we have 3 engines up and running. We can disable some of these engines though. Oh, but that's only going to make the rotors. Oh, that's fine. Alright, so there is our bugged out version here. So here we see maneuvering rotor thrust versus target is -1 versus 0.7, -1, 0.1. That's not a normalized vector. Is this all because the normals are screwed up? And not normalized. So this actually seems correct. Was that whole thing just because my normals were screwed up? Oh my god. I just forgot to normalize, and that was the whole problem. Oh, for fuck's sake. Well, I'm glad it was something dumb. Because if it's something dumb, it means you might be able to avoid doing it again next time. So we'll debug log these out of existence here. Boom, shika boom, shika boom. And we're going to want to have this falter away if we're not trying to move very much. So we've got our throttle override with these dots, but what we need to do is, if that's not very much, we need to make sure that it's not a substantial change. So throttle override times equals target vector minus thrust vector. Well, this is maneuvering. Yeah, so if it's maneuvering, we want those to be aligned, but if our actual heading change isn't much, so if controller dot heading dot change, course change, dot Euler angles, let's go ahead and set this up in another way, because what we need to do is, we might as well do this somewhere else, like inside of our system here, because here we can actually we actually know how far the delta is. We got our thrust vector, we got our target vector. Let's go ahead and get float change intended equals delta.magnitude. And then down here we can set this up. Putting it inside of the get is a little bit iffy, but that should be okay. So, and then we multiply this by change intended. And then here, these are going to be the thrust vector. Okay, so we're going to want to just protected float offset our maneuver magnitude. This is dumb, though. This is a dumb way to do it, and you shouldn't do it this way. I'm trying to combine 3 things into one function, and it's just not great. So we're going to put this here, and we'll make this maneuver magnitude. And that should mean that we thrust more aggressively when we're trying to turn faster, and less aggressively when we're not trying to turn as fast. Let's go ahead and save that magnitude so that we can see it. Debug.log maneuver magnitude. So it's like 1.1, 1.4, 1.6, 1.7. Okay, so it looks like it tops out at about 1.8 given the current rotation. And if I pull it back, it drops down considerably. All right. So it does drop down. It's just that it is too large. So we're going to want to have this modified considerably. We're going to go ahead and make this the magnitude squared, and then divide it by 10. All right, that's a little bit better. And you can see that we max out at more like 0.332. And then if I pull this back to the right, you can see that it stops maneuvering. See, that's much better. All right. So that's our maneuvering jets. The maneuvering jets now exist. Now, I haven't got the maneuvering jets actually turning the ship yet in terms of telling the ship how much to turn. Right now, the ship is still just turning based on a fiat set of numbers. And that's not, obviously not going to be the way that it has to be in the long run. But here you can see that it's working. Let's go ahead and just take these particle systems down a couple notches. These are a little bit aggressive here. Oh, we're in debug view. Normal view, please. And let's go ahead and put in another one on the other side. So delete this rotor, duplicate this rotor, flip it over, yoink, and then pull it out, yoink. Yeah, that's right. Go up to the ship, and then we'll drop in these rockets just for now. Boom. Tell it to reload the object list and then guess at the connections. And then we should work. We should have all of our... let's change the camera because I can't see shit. Colt Zero says color normals. I'm not sure. Sorry, I'm not sure what you mean. I must have lost track of the conversation. So here you can see that we have a nice turning system that's based on how we're trying to maneuver the ship. Now that said, it's not going to work very well until that's actually responsible for moving the ship. I think I can actually handle that. I think I can tell it specifically to do that before signing off. That's something that's possible. So what we're going to do is go ahead and have the ship determine how much it should be moving. There's a couple of ways to do this, and I think that the easiest way is for us to detect thrusting maneuvering engines. You can also have the maneuvering engines tell the ship or the control system how much thrust they are having. So we're going to go ahead and do it that way because it's a little bit less heavyweight. So if we go over to the ship control system, we've got this update, and on this update we do a lot of our alignment stuff. We're going to want to have this be public void maneuvering thrust, and we're just going to make this real basic, where we're just going to have it tell us how much thrust it has and the range it is from the center of the ship. So add maneuvering thrust this frame. Leverage how far you are from the center of mass. So with that in mind, we're going to come up with some basic values here. Public protected float maneuvering quantity equals 0. And up here in update, at the end of a line, we'll clear it out. So maneuvering quantity equals 0. And down here we will say maneuvering quantity plus equals thrust times leverage. Pretty basic, right? Except for that's not really what we want to do, because we also need to multiply it out by mass. And we don't have mass stored here in the control system. Mass requires us to have a container object. So we're going to want to, in this, find that container object. So physics container. So it's a mass graph dot physics container PC equals get component in parent mass graph dot physics container. If not PC, then return debug.log error name plus has no physics container. There we are. Otherwise, what we're going to want to do is figure out how much of that quaternion we are going to execute. We're going to need to know the mass, so float ship mass equals pc.mass. See, we got a center of mass, but we don't have a mass. We're going to need to add that. So we're going to pop on over to our physics container and add in a mass public. It's the same thing, and just copy this whole thing. Mass. And then instead of having a vector 3, we'll just add them together and return the mass. Mass. Float. Perfect. So when we have this, we're going to grab our mass, and then we're going to divide. We don't even need to grab it. We'll just say maneuvering quantity divided by equals pc.mass. Easy enough, right? So if we have that, then what we're going to want to do is take the quaternion that we've built and get that to execute based on how much that value is. So we've got our course change, and that's what we're going to do. So course change. So it's transform dot rotation. Can I just multiply this by the course change? That's not even multiply by. That's like something strange going on here. And this stuff we can all comment out. Colt Zero says, I want to say this is the first time I've seen this kind of normal calculations. Before this, it was generating normals based on samplings from a density field, not the alpha channel of a 3D texture. See, I think he's just using the alpha channel of a 3D texture as a as just an easy way to store the density field or some similar value. I don't think that it's actually like an alpha. I think it's just that's a handy place to put it. All right, so what we're going to do is we're going to see whether or not this works. Okay, so it works, except for it really kind of doesn't work because I'm rotating the wrong thing. It's not transform.rotation, it's ship.transform.rotation. Otherwise, it's just my nose spinning randomly. So here you can see that it's perfect. It locks in great. What we're going to do is we're going to associate that change with the amount of thrust that we have. So course change times mathf dot clamp 01 maneuvering quantity. Perfect, right? And now it shouldn't move at all. It should just be quaternions and floats can't be. Okay, so I have to lerp it to the identity. What a pain in the ass. Quaternion dot slurp identity quaternion dot identity comma course change comma mathf dot clamp. There we are. And now that should have no motion at all because our maneuvering engines haven't learned how to talk yet. So that's what we're going to do. We're going to have our maneuvering engines talk now, which we do by going into our maneuvering engines and telling them to use this maneuvering thrust. So to do that, we're going to go down here into this throttle, into this rotor, and we're going to take this throttle that we're doing. We're going to go ahead and say controller.maneuvering thrust, and then we want to pass it the thrust and the offset. So the thrust is t.throttle times t.max thrust. And the offset is the offset of the maneuvering thruster from the local space, which we actually determine back here with this. So we'll go ahead and put this here, but this is flabby, so we'll just do a little bit of optimization. Vector 3 PCOM equals physics container center of mass. Oh, except for we're doing it, that's fine. We're doing it from the component center. We really should be doing it from each thrust center. Okay, so we're going to have to get our protected float offset from center of mass. And then here we're going to say offset from center of mass equals offset from center of ship.magnitude. To do make this the sum of the centers of the maneuvering thrusters rather than our center. Anyway, that offset from center of mass gets stuck in here, and that should be good. Any barfs? No barfing? You done barfing? All right, let's take a look. Okay, so you can see that these values are dramatically too high. So that's mostly probably because these maneuvering rotors, no, they're too high even for that. There's something screwy going on with this. Offset from center of mass as being too important. That's what the problem is. So we're going to go over here into the controllable ship systems, or ship control system. Here it is. We're going to go ahead and just divide this by a flat number like 1,000. There we go. So you can see that the ship's thrust actually seems to work now. And if we try and move the ship around, the thrusters actually bring it to bear in a meaningful way. See? Isn't that great? And if we turn on our main thrusters, we can get everything all at once. So let's go over there. We broke some shit. That's okay. We'll live with it. We are not moving very fast. Are we moving at all? Oh, I disabled our forward movement, didn't I? Here it is. This rigid body slurping is... So this is us setting our rigid body. This is also something we're going to have to take care of by calculating out the actual amount of thrust. And we have those calculations ready. We're just not ready to use them just yet. That'll be next week or maybe off screen. So you can see that we have some fairly good maneuvering here. It feels fairly natural for us to be able to do this. And the maneuvering jets actually do their job, which is nice. They are firing in the correct direction, in a convincing direction, and overall, they give a good feel to it. What do you guys think? Seems good? Seems good? Colt Zero says Coolio, which I think is aimed at me. So things are starting to come together now. We're going to go ahead and next week we'll be putting together a lot of other values. So that's going to be fun and entertaining. It looks like I have accidentally rotated the ship funny. That's going to be something that we're going to work with as well. Oh, of course, because we're no longer... look rotation is incorrect. I can fix that. This from to rotation, it's got no look vector. Okay, so right now our problem is that there's no look vector. We're going to want to bring that look vector into alignment. And to do that, we're just going to do a quick ship.transform.rotation again. So ship.transform dot rotation equals quaternion dot slurp quaternion ship.transform.rotation comma quaternion.look rotation with ship.transform.forward and the ring up. With the time.delta time times 2. There we are, that should do. And let's see whether or not that keeps us from randomly skewing in strange directions. Because that we don't want to we don't want to slew like that. There's no real good reason to do that. Alright, so that seems like it's working. We're no longer getting any really, really awkward skewing. we could also introduce the slewing, the spin, into the quaternion. The only reason that we haven't is because the function we're using to determine this quaternion doesn't contain an up vector. This is a raw 2-vector system. Peter Nerlich says he's pretty jealous of me. This is just particle effect colors, but wouldn't it make more sense for secondary thrusters to be cold gas? Yeah, obviously this is all stand-in crap. I literally just cloned the standard thruster systems. Now in this case, these would be hot plasma thrusters, because these are simply vents that draw off of the main thrust's output. So in this case, they would be similar colors. They should look different. They should be a shorter, heavier, single-colored unit rather than a dual-colored unit like we've got here. But in this one case, they would not be cold thrusters or anything like that. These are hot vents. But they are also a little bit silly because they are currently set to an incredibly high thrust value. That's the rotors. The rockets are set to be just as powerful as the main rocket engines are, which is obviously no good. Bring it down to 10, and that'll cut our speed down rather dramatically, our turning speed down rather dramatically. So I think that dividing by 1,000, which was arbitrary, might be a little bit much, and we might need to make it more like 250. Magic number. That's good. We don't want to be too spry with just these jets. This is probably still too spry, but we can always work with it later. So if I take these particle systems, I can change their values a little bit, because right now what we've got is color over lifetime, which is gold, I believe. Yeah, the blue gold here. What we can do is these guys, we can just delete these, and then we can go in here and remove them from the update. And that way we'll just have the red flame. We can also take this red flame and we can change it so that it is smaller and slower. Yeah, that's a little bit more like what I had in mind. So there's something screwy going on here because we're getting a fair amount of turning before the thrusters actually come on. Maybe we're not. Maybe it's just an illusion caused by the hinges. I think it's just an illusion caused by the hinges. That's cool. Whoa, that's fine. We'll figure out some edge cases later on. All right. Peter Nerlich says that they should probably get wider rather than smaller. You're probably right. Let's go ahead and take the size of our lifetime, and we'll change it to this. That didn't really change it very much, did it? It's fine. We'll obviously be redoing all of this stuff later. For now, however, I've got to take a screenshot so that I can get a good glimpse of it. Paste. All right, well, thank you for stopping by, everybody. I'm going to go ahead and call this a day. I got more done than I expected to. I was feeling really, really bad for a little while because I couldn't figure out what the heck was going on, and I just had to normalize something, and I'd forgotten to normalize it. And it was pretty depressing. I was like, I can't figure this out. But I ended up getting more done, as much done as I'd wanted to get done, which is always good. On the other hand, I spent an extra half hour on it. Now I'm going to have a really late dinner. I will see you all on Sunday, if any of you want to be there. Otherwise, just see you later. I imagine that once I get back into the Galactic Line level content, people will probably start showing up again in more numbers. Right now, it's just a bunch of random boxes putting up some very basic particle effects. And obviously that is not as appealing. So I don't have the numbers that I had a couple months back, but that's fine. Going from 10 to 4 is not a big deal. And I will see some of you later. Where is my stop button?